Hello, this is a second video about inflation in the course Engineering Economics INEN 2373. In this video, we're going to talk about how inflation affects the forecast of the cash flows in our projects, and how the minimum attractive rate of return should be adjusted for considering inflation. Let's consider here a project in which the cash flows are depicted to be in year 0, 1,000. That's the initial investment, so it's a negative cash flow. And then you have annuities of 400, 4 annuities of 400 each at the end of time of t equals 0 through 4. What I have here in the left column is the present worth of each one of these quantities brought back to the present using a discount rate or minimum attractive rate of return of 10%. So when we add all these quantities together in this column, we obtain 267.95. And that would be the present worth of this project discounted at 10%. So nothing changes here except with the consideration that inflation has not been taken into account in this project. In other words, when we estimated each one of these 400, these 400 come from an estimation of how many hours we're going to work, how many how much we're going to spend in consumables. It could be gasoline, it could be tires, it could be wages and salaries to workers, how much investment we need, and all those make the assumption that the prices in gasoline and other consumables are not changing. We are only considering maybe changes in the amount of units that we're selling, but it's not considering any changes in the prices. So how would this change if we have to take into consideration changes in prices? Well, if, say for instance, we would expect an inflation of, let's consider an inflation of 4%. That means that the prices will change, but right now we are at year 0, so the initial investment will be the same. The initial investment at t equals 0 would be equally $1,000. But at the end of next year, the amount of dollars that we will receive will change, not because we change the units, but because the prices actually changed. So the actual price that we're going to get would be 400 times 1.04. That's 416. And then if we make the assumption that inflation is the same amount every year, then the next year we're going to have 4% for the previous year plus 4% in the second year. That's 1.04 square. So the these $400 would translate into 1.04 raised to the 2. If we continue with this process, you can see what the pattern is. I can simplify this expression as the 400 times 1 plus the inflation, if inflation is to remain the same, times to the t. And that is going to be the effect in the next 4 years. So even though we're receiving 467, say in 4 years, in the fourth year, $467, that doesn't represent we're making more. It's just a nominal value more, but we're not being able to purchase more. Our real wealth in terms of how much we can purchase, it is not changing. It is the same $400. So the question is, how do we value it? In some instances we would be required, or it would be faster or easier to take into consideration the inflation in the forecast of your projects, because you want to make certain that some items are going to cost more than others. Maybe some items are actually going to drop the prices, and the estimation on the cash flows that you have, you need to take into consideration that aspect. So before we can compute the present worth for this project, we need to have an estimation of the correct minimum attractive rate of return that we need to use. So in order to compute the minimum attractive rate of return that we will use, let's denote that with letter I. That minimum attractive rate of return would be the desired minimum attractive rate of return in the absence of inflation plus the inflation denoted with F plus the product of V times F. And that's the expression that we're going to need. So in the example that we had before, the D was 10%. That was our minimum attractive rate of return when we didn't have any inflation. We are estimating inflation at 4%, so we can write that as 0.04 or 4%. And then, of course, this would be 0.1. And then, therefore, D times F is 0.004. So the minimum attractive rate of return that we need to use is now not 10%, but 14.4%. And if, as long as we're consistent and we use this as the minimum attractive rate of return, then we will obtain the same present worth for the project. Let's look at that. So now what we need to do is the adjusted minimum attractive rate of return, adjusted for inflation, is, we said, 14.4%. And we're going to use that to compute the present worth just like we did before. These were the cash flows. This is going to be the present worth with adjusted minimum attractive rate of return. So we take each one of the cash flow, divide them by 1 plus this rate raised to the t, and we keep the 1000, and as we what did I do? Okay. Oh, I'm sorry, it has to be 1 plus. Okay. And clearly, as you can see, the columns, these two columns are the same, so when we add them together, when we add that column, of course, the answer is going to be the same. So it is going to be the same present worth as long as we make the proper computation of the adjusted minimum attractive rate of return for that considers inflation. Remember that each one of these numbers that we have, each one of these annuities of 400, can probably come from 100, maybe 1,000 estimation of how much we're going to consume, how many units, at what price, and so on and so forth. And all these numbers need to be adjusted for inflation, maybe in real life, and it's a very time-consuming process. Make sure that when you take into consideration your inflation, you are consistent and decide whether or not you're going to use inflation. This is the only week and a couple of videos in which we are actually using inflation. In the rest of the program, we are not taking into consideration the changes in prices due to inflation. And even though without inflation there is still the effect of the time value of money, when we have inflation, we have to take into consideration both the effect of the time value of money and the value of the effect of the inflation itself. So here you see how we can combine both.